Hi, my name is JB Despujol, and I'm a solutions architect at CAST Software. The goal of this video is simple, to see how an AI agent answers an impact analysis question in two very different situations. In the first, the agent relies only on the source code open in Cursor, and in the second, it has access to that same source code plus the structured data from CAST Imaging delivered through its MCP server. Same code, same question, two different levels of context, and we will see what that changes. First, a word on where that second source of context comes from. CAST software builds solutions that provide software intelligence to your existing systems. CAST Imaging is the solution that we will be focusing on today. It reverse engineers an entire application and maps every dependency from the UI through the backend down to the database into a structured model you can explore and query. That's the map we're about to hand to Cursor in the second case. Today, we're working with a web application that hosts cooking recipes. It's a deliberately small code base under 100,000 lines of code. It's small enough to reason about, but real enough to make the point. I am now putting myself in the shoes of a developer, and I'm given the task to change a part of the flow for editing a recipe. Looking through the code, I found the entry point for that flow, this edit recipe.aspx page. Before I touch anything, I need to understand the blast radius. What else in the system a modification here could affect? So now let's go directly in the agents window of Cursor. So I already asked the agent and I deliberately told it not to use CAST imaging. The prompt I gave it was, I want to modify the end-to-end flow related to this edit recipe.aspx page, count and list all the database tables that can be impacted by this change, precising again without using the CAST Imaging MCP server. The agent read the code it can reach, followed what it can infer, and came back with 4 database tables it believes could be impacted. Hold that number in mind. The agent did its best with what it found by reading files in the directory. Ahead of this demonstration, I already ran the recipe application through CAST Imaging. So now let's ask the exact same question, but this time we give the agent access to the CAST Imaging MCP server. That connection lets Cursor tap into structured, digestible data produced by reverse engineering the whole application. The agent gathered that data and answered again, and this time it reported 6 tables, not 4. And here's the part that matters. Those 6 tables are not a guess. They come straight from CAST Imaging, and we can see exactly where they come from. So this is a visual representation of the end-to-end flow of edit recipe.aspx that has been reverse engineered by CAST Imaging. We can walk down the dependencies with the C# classes, the C# methods that are part of it, as well as the SQL store procedures that are finally leading to the 6 database tables at the end of the chain. It's the same 6 tables Cursor named once it had this data. The Cursor number matches what the dependency graph shows. So this was an easy case, under 100,000 lines of code with one clean flow. Real enterprise systems are millions of lines, decades of history, multiple languages and frameworks tangled together. Exactly the environment where a mistable isn't a rounding error, it's a production incident, a broken migration, or a compliance gap discovered too late. If structured context changes the answer on a small recipe app, imagine what it does when the blast radius is measured in hundreds of objects instead of 6. And that's the value of giving your AI agent a real map of your system, not just the plain source code in your IDE. And this is how you can modernize at scale even your most complex applications with confidence by using Cursor powered by CAST. Thank you very much.